Okay, factoring polynomials. So polynomials expressed in factored form if it's written as a product. The following polynomials are expressed in factored form, right? So product of two binomials, right? Because we're factoring quadratics. And a quadratic has a squared term, right? It's going to be the product of two binomials. Each of these polynomials can also be expressed in simplified form. Okay, so simplified form is taking this. How do we go from from factored form to simplified form? FOIL, right? So we multiply it out. And how many products are we going to get? 4, which will then collect into 3. Sometimes 2, if it's a difference of squares, right? That's special product. And we looked at these in 10C, right? Special products and factoring. So when I discuss factoring, it may be a different way than you've done. If you've got a way that you're good with and you're comfortable with, by all means use that. So all I really care about is that you can factor. How you do it is up to you. If you found some neat way on the internet, that's cool, right? If you want to use, there's all kinds of different methods that can be used. I'll show you a few. If you like them, great. If you've got your own way, by all means, right? The important thing is just that you are able to factor. Generally, don't need to see much work in factoring, right? It's just sort of like, here's the thing, and then here's the factored form. Okay. Sometimes we do have to show a couple of steps, and I'll show you where that's appropriate, right? So showing work. Anyways, so each of these, to simplify the polynomials, you multiply to remove brackets. So here's how I would multiply this one, right? This is how I would do it, right? So it's kind of 4, right? So it's like x squared minus 5x plus 7x, right? I know those are the two terms they're going to collect. So minus 5 plus 7 gives me plus 2x, right? Now, you can write down minus 5x plus 7x, okay, minus 35. And then x squared plus 2x minus 35. Okay, so if I'm multiplying it, just me, for the sake of having to multiply that, I'm just going to show that final answer, right? I'm just going to go x squared minus 5 plus 7 is plus 2x minus 35, right? So either way, you do the full 4 thing. Okay, so here we get 10x squared minus 15 plus 12. So what's that? Yeah, so minus 15x plus 12x, right? So we're going to be writing we're going to be writing 10x squared. Okay, and then I'm just doing that one in my head, right? Now, if you're more comfortable writing out the 4 terms, by all means, write out the 4 terms. Okay? It's not a contest. Okay, and then minus 18, right? Okay, so this one I recognize as a special product, right? It's a difference of squares. So when we have the same 2 terms multiplied, but one is a plus and one is a minus, then when we FOIL it, what do we get? Well, 81x squared minus 36x plus 36x, right? So the middle term is gone, right? The x's. So if you want, you can write it out. So here, I'll write it out. And then we've got minus 16. So that is 81x squared minus 16. Right? That's simplified form. That's when we get 2 terms out of the product of a binomial, is when we have these products. And actually, the special name for this is the excuse me. This term is the conjugate of that term. This term is the conjugate of that term. And what the conjugate means is it's the same 2 numbers, same 2 terms, right? 9x and a 4, once with the plus sign, once with the minus sign, right? So they're called conjugates, and their special product is that the outer and the inner products are the same but have opposite signs, so we can go straight to difference of squares, right? In this one, there's a 3 out front. So we're just going to keep that 3 out front. We're going to multiply the 2 binomials together. We're going to collect them down into their 3 terms, and then we're going to multiply through by 3. Okay, so that's the order we're going to do it in, right? We're going to multiply, so it's going to be 3 times, now I'm going to multiply these guys out. So 8x squared minus 6 plus 20 is going to be plus 14x minus 15. Okay, this time I'm not writing down the 4. I'm not comfortable writing down 4. I'm comfortable writing 3. Okay. But you have to be comfortable enough in your mental math skills to be able to add or subtract these numbers. Okay, and then that's equal to 24x squared plus 42x minus 45. Okay, and that we call the simplified form. Okay, so factored form, simplified form. To multiply. Process of expressing a polynomial as a product is called factoring. So basically, what we would do to factors, we would have to take this and work it back to that. Right? So we're looking at a trinomial, and then we're saying, okay, how do we factor that? All right, so how do we factor? So if we remember, x plus 7 times x minus 5 is x squared plus 2x minus 35. And we want to be able to factor that. So here's how I factor a trinomial of this form. Right? And this may work for you, might be a little different than you've seen before, might be the same, might work for you, might not. There's a ton of factoring videos out there, right? So your responsibility is to be able to factor. I look at this and I say my last term is negative, which tells me, and where did the last term come from, right? It only came from this number times this number. So that tells me that one of these is positive and one of these is negative, right? That's what it tells me. So it says, I need two numbers that multiply to 35. And since one is positive and one is negative, then they differ by, right? The difference between those two numbers has to be this middle guy, right? That middle number, right? Because one is positive, one is negative. So when you add and subtract, right, you're going to get a difference. And this tells me that the positive factor has to be bigger, right? Because I'm going to end up with a plus 2. So what's the connection between the values factor? The minus 35 only comes from the two last numbers. The x squared only comes from the first two, right? So the FOIL, the F in FOIL gives me the x squared. The L in FOIL gives me this last term. And it's the outer and the inner. So the connection between the values and the factors and the two is that when this is a minus, that these two numbers here will differ by 2. When this is a plus, then what does it tell me about the signs of these two guys?
They're both positive.
They're both positive or they're both negative, right? So you're both right. They're both the same. Which means if they're both the same, when I collect them, they're going to add up to make a bigger number, right? Either a bigger positive or a bigger negative. So when this says we must find two numbers that multiply, so I just say we find two numbers that multiply to 35 and differ by 2. And if I had, so let's do another one then, just to kind of, so if we had x plus 7, x plus 5, that would be x squared plus 12x plus 35. So this time I'd be looking for two numbers that multiply to 35, because that's positive, and add to 12. Yeah.
How do you know if the signs are supposed to be like both negative or both positive if the last one is positive?
Then you look at the middle term.
Okay.
Because if these guys were both negatives, then we get x squared minus 12x. So positive last term says both signs are the same. And what are they? They are the sign of the middle term, right? So if the middle term is negative, then you know, well, the only way I'm going to get negative 12 out of here, I can't do that if I have two positives, right? I'm going to get a positive 12. So this is a plus. I know these guys are both the same sign. Which sign are they? They're the sign of the middle term. Okay, so I'll show you that as we go through, because now we're just going to factor each of the following, right? So before I do anything, I can write down two brackets. I can say my last term is positive, which means that both of these guys have the same sign, and which sign do they have? It's got to be a plus, right? Because that's a plus. So this is what my factored forms looks like, right? Before I even worry about numbers. And I'm just doing that based on the fact that, hey, the last term is positive, so both numbers have the same sign, and the middle term is positive, so they're both plus. All right, two numbers that multiply to 12 and add up to 7, 3 and 4. Doesn't matter what order you write them in. Okay, a plus 3, a plus 4. Now, key point. Anytime you factor, take a moment, FOIL it back out, just quickly in your head. Okay, just go a squared plus 4a plus 3a is plus 7a plus 12. Okay, because likelihood, if you're going to make a mistake factoring, is you're going to get one of the signs wrong, and when you just go and FOIL it back out again, you'll say, wait a sec, I don't have that middle term anymore. Oh wait, yeah, they're both supposed to be positive or something like that, right? Like you can fix it. Okay, this is B, and what sign am I putting in here? Both negatives, right? Okay, so this is positive. That tells me that both signs have to be the same. Middle term is negative. Okay, two numbers that multiply to 15 and add up to 8.
3 and 5.
3 and 5. 3, 5, b squared minus 5 minus 3 is minus 8 plus 50. Okay, good. C squared minus 2c minus 35. So I know that I've got 1 plus and 1 minus, right? And I need two numbers that multiply to 35. Now, since the last term is negative, they differ by 2. What could those two numbers be?
7 and 5.
7 and 5, right? Okay, where does the 7 go?
Minus.
With the minus, right? Why? Because we know the bigger number has to be negative. Okay, so we go 7. And then we check, right? Because we can FOIL stuff in our head really quick. So we go c squared minus 7 plus 5 is minus 2 minus 35. Good. Okay, because if you get it wrong, you know, I mean, in 10C or on this worksheet, getting it wrong is just sort of like, oh, you got it wrong. But in 20-1, getting it wrong means, and now everything you do from this point on to solve a problem is wrong. Okay, we don't want that. Okay. So you do this one. However, right, if you've got another way of factoring that works for you, just say, yeah, I don't know, this is science stuff you're talking about, whatever, I can just factor this, and by all means, please just factor it. All right, I got a negative, so that's a plus and a minus, and there we go. There's two numbers that'll do that, I think. So we got d squared minus 8d plus 9d is plus 1d minus 72. Next one. So the next one actually requires common factoring. So the first step in any factorization is to try and pull out a common factor. In this case, the 2. So we say, hey, all of these guys are even. So they're all divisible by 2. So I'm going to pull a 2 out, right? If I can, this way I get m squared by itself, right? And now we look at this and we say, okay, so the 2, it's still there. I got two brackets. I got an m plus and I got an m minus, right? Last term is negative, so that tells me that there's... I need two numbers that multiply to 4 and differ by 3. 4 and 1. And the larger one is positive. So there we go, right? Now if I multiply that out, I get m squared minus m plus 4 is plus 3m minus 4. And then I multiply this out, 2m squared plus 6m minus 8. Next one. I don't want a half in front, so I'm going to take the half out as a common factor. So 1/2, okay? So n squared. Now, it's going to be a minus because it's got to have that sign. Half of what is going to give me 3? Half of 6. So this will be 6n, right? And half of what gives me 4? 8. Okay, now check this, right? 1/2 n squared minus 3 plus 4. Okay, good, right? I've done that one correctly. Okay, it's a little tougher because you're dividing by a half, so you're saying, what's 3 divided by a half? And I don't want to do that. So I just say half of what is going to give me 3, right? Half is 6. Half of what is going to give me 4? Half of 8. So we got the 1/2, I got an n. They're both minus, right? Okay, last term is positive. Need two numbers to multiply to 8. Since they add to, since it's a positive 8, they're both the same. Sorry, they have to add up to 6, right? So what are they? 4 and 2. Okay, so n squared minus 2 minus 4 is minus 6 plus 8. Okay, any questions so far? No? Easy peasy. Okay, there's some more. This page got some weird stuff on it. Okay, so let's take the 0.3 out as a common factor, right? So you get x squared plus. Okay, now I might want to use my calculator at this point and go, all right, what's 1.2 divided by 0.3? Or I might just say, hey, that's 4. And then I say, what's 13.5 divided by 0.3? 45?
Yeah.
Okay, so minus 45. All right, so we were able to common factor out that 0.3. Now we're left with, okay, so the 0.3 is still there. I got an x plus and an x minus. Two numbers multiply to 45 and differ by 4.
9 and 5.
9 and 5. Which one goes here?
9.
9. Okay, you check x squared minus 5x plus 9x. This is really important to check with these, right? I mean, less so if they're both pluses. But even then, sometimes you found two numbers that multiply to the thing, but they don't add up to the one that you want. So that's why just a quick check. Okay, x squared minus 5 plus 9 is 4, and then minus 45. Okay, it's all good. All right, what the heck do we do here? So, all of these guys up till now, this is a quadratic in x, right? Because it's the x that's being squared. This is a quadratic in n, because it's the n that's being squared. This is a quadratic in m. This is a quadratic in d. What's this a quadratic in?
X plus 2.
X plus 2. So, we got two things we could do. We could just straight factor it. I kind of like that. So what I'm going to do is I'm going to solve a simpler problem. Right? So I'm going to say, let A equal x plus 2. So everywhere I see an x plus 2, I can now write A. So how do I write this guy then? So A squared minus 3A minus 40. Okay, that one's easy to factor, right? So can you factor A squared minus 3A minus 40? Then do it. Okay, we got a plus, we got a minus. Plus 5. Minus 8. Okay, so we took, what we don't want to do is expand that, right? I do not want to go x squared plus 2x plus 4 minus 3x plus 6 minus 40, and then I could, right? But the question is why? You don't need to, right? Now, all right, the question never had an A, did it? So what are we going to do now?
Replace A with X plus 2.
We're going to go in, we're going to replace A with x plus 2, right? So just go back up here. So it's going to be x plus 2 plus 5 and x plus 2 minus 8, which is x plus 2 plus 5 times x plus 2 minus 8, which is x plus 7 times x minus 6. Okay, now if you multiply that back out, you are not getting the original thing, right? So this one's a little bit harder to check. The way you could check this is if you multiply this out, you're going to get x squared plus x minus 42. If you expanded all of this and collected all the terms, you would get x squared plus x minus 42. Okay. I wouldn't at that point do that, right? It's not worth it. What you could do, if you wanted to check these guys, right, at the end of the test, when you have some time, right, you could go and graph this, and you could graph this. And if you do, what should you see?
The same one line.
The same line, one line, right? Now, on the color ones, it's really nice, right? Because it'll draw like a blue line, and then you'll see a red line go right over top of the blue line, and that's pretty obvious. On the other one, you'll see it draw the first curve, and then you'll see in the upper right of the calculator, it'll still be flashing away, and it's drawing the second curve, and you're not seeing a second curve that looks different, then you know, okay, hey, they really were the same. Okay. Now, that's only after you finish the test, and you want to go back and you want to check a particular factorization, right? Your other way is you can expand this out and you can expand that out. Okay. I'm not going to do it, but what's this a quadratic in?
T squared minus 3t.
3t squared minus 3t plus 4, right? Now that actually does factor, right? I need two numbers that multiply to 4 and, no, maybe that doesn't factor. It doesn't actually factor, does it? You can't find two numbers that multiply to 4 and add up to 3. Okay, so what are we going to do?
Let a
We're going to let a
equals t squared minus 3t.
Yeah. We are going to solve a simpler problem. So we are going to say, I don't want to factor that. Not the way it looks, right? That's ugly, and I'll probably make a mistake. But now what do I end up with? A squared minus 10a plus 16. Okay, well, I think I can factor that, right? Two numbers multiply to 16 and add up to 10. So 8 and 2, right? Okay, they're both minus, right? A minus 8, a minus 2. Okay, then check that out, right? I mean, expand this. A squared minus 2a minus 8 minus 10a plus 16. Okay, good. But it was never a, was it? So what do we do now? Now we go back in, and we replace the a with a t squared minus 3t plus 4 minus 8. And we replace the a with a t squared minus 3t plus 4 minus 2. Now I'm going to save a line. I mean, up here when I wrote this line, I really could have just taken this and gone, oh, that's x plus 7, and taken this and gone, oh, that's x minus 6. So this is t squared plus 3t, then what? Minus 4. And this is t squared plus 3t. Wait, sorry, it should be minus 3t. If only I had written a minus, I could have turned that into a plus really easy, but just putting a plus down. Okay, so sorry, so it's t squared minus 3t plus 4. I like to keep it in brackets just to, and then minus 8. And then it's t squared minus 3t plus 4. And then minus 2. Okay, so t squared minus 3t minus 4. That needs to be in brackets, right? Because it's something, we're actually going to factor this now. And then t squared minus 3t plus 2. Okay, so t, that's a minus. We got a t plus and a t minus. This one? I got.
Added together already, sorry.
Yeah. So it's plus 4 minus 2. Skipped a line on there, right? I mean, because really removing the brackets, I like to keep it in brackets, just reminds me that this was the term. I'm going to assume each of these guys factor, so that's going to be a t minus, t minus. Okay, so first, this one. So two numbers multiplied to 4 differ by 3. Okay, 4 and 1. Larger one is negative. So 1, 4, right? T squared minus 4 plus 1 is minus 3t minus 4. The two numbers are multiplied to 2 and add to 3. 2 and 1. T squared minus 1 minus 2 is minus 3 plus 2. So there's your factored form. Okay? You do not want to square that t squared minus 3t plus 4, right? You'll end up with 6 terms. Then you'll end up with something that's got a fourth power. What you won't end up with is this. You will not end up with the correct answer. Okay? And you will waste a whole lot of time doing it, right? Like seriously, you'll spend 10 minutes trying to do that, right? So, you know, I want to use what George Polya, a Hungarian mathematician, solve a simpler problem. Well, look, the thing that's being squared is also the thing that's being multiplied by negative 10. So let's just replace that thing with a variable. And then look at this and say, oh, I can factor that. That's easy. Okay, but now I need to replace, right? I mean, it wasn't an A. It was always this. Okay. Factoring trinomials in the form ax squared plus bx plus c. So you recall that 5x plus 6 times 2x minus 3 was 10x squared minus 3x minus 18. So where does the 10 come from? 5x. Yeah, so 5x times 2x, really the 10x squared, right? So where does the 10 come from, right? It's the first factor, right? Again, it's first, right? Where does the negative 18 come from? That's last. Okay, that's a negative 18. Now, I can't do this whole middle differs by 3 thing, right? Because that doesn't fit now. Yeah, it does, but I don't do decomposition. I refuse to show you decomposition. I will show you another method. In order to factor ax squared plus bx plus c, we got to find two numbers that multiply to give us the 10. We got to find two numbers that multiply to give us the 18, be it positive or negative. I don't worry about that. And the outside and inside product must add 2, so that's negative 18, and that's negative 3. Okay? Just going to fill those in so you can fill it in, but that's not how I do this. So I'm going to show you two things, right? And it depends on the leading term. So I'm going to show you a method called guess and check, and I'm going to show you a method called, for lack of a better word, call it over the rainbow. Okay? You can use over the rainbow instead of guess and check at any point. So over the rainbow is a mechanical method, right? It means I need to find two numbers that do this, and the numbers do this, right? And so it's just looking for the numbers. Guess and check is a little bit more, all right. So here's guess and check, right? If I want to get 2a squared, then I know that I have to have a 2a there, and I have to have an a there, right? Only way you can get 2a squared. There's no other way to get 2a squared, because 2 is prime. Therefore, 2 is 2 times 1. Now, I need two numbers that multiply. Now, I know everything's a plus, right? That's a plus, that's a plus. I can't have a minus sitting there. I need two numbers that multiply to 15. Likely 3 and 5, right? Possibly 1 and 15, but doubtful. Okay, so 3 and a 5. And the 3 and the 5 got to give me this 11. So if I put a 3 there, I'm going to get a 6a. And if I put a 5 there, I'm going to get a 5a. And 6a plus 5a is 11a. And that's the factored form. And that's called guess and check. Right? So I start with the fact that this is a 2a and this is an a. That has to be that. I then go to the fact that, well, okay, everything's plus, so these guys are pluses. I could put a 1 there and a 15 there. That would give me a 2 and a 15, which would give me 17. I don't want 17. I could put the 15 there and the 1 there. That would give me a 30 and a 1, which is 31. Don't want a 31. So it's not 1 and 15, right? It's 3 and 5. And generally, go to 3 and 5 first, right? Don't go to 1 and 15. And then I could put the 5 there, but the 5 there gives me a 10 and a 3. That's a 13. It'd be good if it was a 13a, but it's not. So I put the 3 and the 5 there. All right. I will also show you over the rainbow for this method, right? So here's over the rainbow. So this is one, right? And basically in guess and check, the only work you're showing is you're not showing any work, right? There's nothing. right? It's just, hey, here's the answer, right? And it's right or it's wrong. Hopefully it's right. Here's over the rainbow. You start out with a 2a and a 2a. Now, what's the problem with that? I'm going to get 4a squared. I have one too many 2's, right? So I'm going to put a 2 on the bottom. Now, here's the over the rainbow part. I need two numbers that multiply to give me 30 and add up to 11. What are the two numbers? Multiply to 30, add to 11. 6 and 5. Doesn't matter which one I put where, right? So I'm just doing normal. This is plus, so plus 6 plus 5. Does the 2 go into this? Does the 2 go into this? How many times? A plus 3. What do you got? A plus 3 times 2a plus 5. Okay, so that's mechanical factoring, right? Mechanical as in, you put a 2a, you put a 2a. All right, I need two numbers to multiply. Over the rainbow, you got to go from the first line. I need two numbers that multiply to 30, add up to 11. What are they? I put them in, and then I get rid of the 2 on the bottom. Okay, now we're going to do each one of these both ways so that you can see. Okay, this guy, 3b and b. The only way, so when that first number is prime, the only way you're getting it is to have that number with the variable and then 1, right? That's it. The only way to get 3b squared is 3b times b. The only other way would be to go b times 3b, right? That's it. It's a 3b and a b. Two numbers that multiply to 8. Okay, 4 and 2. Now, they're both going to be negative, right? Because that's a positive. So I know these guys are both negative. If I put the 4 there, I'm going to get a 12. If I put the 2 there, I'm going to get a 2, and that'll give me 14 because they're both negative. So it's not a good idea to put the 4 there. If I put the 2 there, I'm going to get a 6. So 3b squared minus 6b minus 4b minus 10b plus 8. Okay, that's guess and check. The other possibilities were a 1 and an 8. Very rarely, if it's a 1 and an 8, this is going to be a much bigger number, right? Like that's guess. Guess and check is, I've done a lot of factoring, and I just have a feel for which numbers are probably the factors. And that doesn't mean I'm right, and it does mean I need a good eraser, and I have to do this stuff in pencil, right? Because I'll be writing down stuff, and then I'll be like, oh, that didn't work. All right, here's the other way. Or, okay, what do you write down? 3b, 3b, and a 3. Okay, we go over the rainbow. I need two numbers that multiply to 24. And add, right, because this is positive, they have to add up to 10. 6 and 4, right? And they're both negative. Now I got to get rid of the 3 on the bottom. What do I do with it? Well, it'll go into this, right? How many times? b minus 2. How does this compare to that? They're the same. What should you do when you're done? Check it. Okay, so I don't care if you use over the rainbow, you still have to check your factorization, right? And the reason is the next 3 marks of the question depend on you having done a correct factorization. And the other reason is if you factored it wrong, it's now going to take you 10 minutes to come up with an answer worth 0 marks instead of 2 minutes to come up with an answer that's worth 4 marks, right? Because you're working with a correct factorization. Okay, 8c squared plus 2c minus 15. Now, this can either be 8c and 1c, or 2c and 4c, right? 4c and 2c. I am going to go with, experience tells me it's probably this. Okay, but that's what? That's a guess. Okay, 15, probably 5 and 3, right? So let's put the 3 there because I'll get a 12, and the 5 there because I'll get a 10. And I want the difference between 12 and 10, right? But I want the 12 to be positive. So there you go. That's the factored form, right? You can check it. Nice. Yeah, okay, it actually is right. I just ran another quick check on it. That's guess and check, right? That's what it does for you. Okay? Now, you don't have to do guess and check, right? If you can, I think it's good, right? Like, I would start everything with guess and check. And then if I run into problems, then I'll go to over the rainbow, right? Because that gives me a method to fall back on. But for those of you that like mechanical methods, we'll do the mechanical method, right? Because this time it really is, it's in doubt, right? It could have been 8C and 1C. Experience tells me it's usually not the extremes, right? It's not going to be an 8 and a 1 with a 1 and a 15, right? Because you're going to get really big numbers. You know, 8 times 15 is like 120, really big numbers. All right, over the rainbow. Okay, now what do I write? Got to put an 8 on the bottom, right? Because this is going to give me 64. Okay, I need two numbers that multiply to whatever 8 times 15 is, 120. Because that last one is negative, they multiply to 120, they differ by 2. Which means that they're pretty close together. Right. So if you can't figure out the numbers, and you know they're close together, go with the square root. What's the square root of 120? 10.95, right? So that means you're looking at 10 and 12, right? So those are the numbers, right? So, you know, sometimes this could be a lot harder to come up with the numbers, right? And you have to play around a bit. But if the numbers are close together, start with the square root of the number because, you know, you're just going to have to move out a little bit from there, right? If they're further apart, it probably is just a little more obvious, right? Like if they differ by 37, you go, that's 40 and 3, right? All right, what did we say they were? Now, the bigger one has to be plus, right? So I got to go plus 12 and minus 10. Okay, we know the bigger one is plus, right? Because you got a plus 2 there. Okay, so we know they differed by 2 and they multiplied 1. Oh, well, now we got a problem, right? Because does 8 go into this? No. Does 8 go into this? No. All right, so here's how we're going to fix this. I'm going to write 8 as 4 times 2. Does 2 go into this? Yeah. How many times? 4C minus 5. Does 4 go into this? How many times? Does that bear resemblance to the original answer? Yeah, it just took longer to get there, right? But it's okay. Because do I care how you factor? I do, only in the sense that it be done correctly. Okay, so how much work are you going to show? Well, if you're doing guess and check, you're going to write down the answer. And occasionally there's going to be some erasing marks in there because you'll have written the wrong thing and you'll have had to go back and say, oh, I got to change the sign on this, or oh, I'm not getting the middle number correct. Right? So guess and check, I mean, I would give it a minute. Right? If I'm factoring something and I can't do it in a minute by guess and check, then I'm going to go with the over the rainbow. Okay. There's another method called decomposition. That's, you know, if you want to learn that, go on YouTube and type in factoring by decomposition. Over the rainbow basically does the same thing, it just does it cleaner. Decomposition, you know, and if you've used decomp and you're good with it, by all means, keep doing it. Okay, factor this. I don't care how, just factor it. So use over the rainbow, use guess and check, use the method of boxes if you learn how to do it by factoring with little boxes and stuff. And I don't know the factor. I don't have a key to this anywhere. Like, I mean, somewhere I expect there might be one. So if you're watching me, I'm doing guess and check.
Just 14, 15. It's D's, by the way, not C's.
Yeah, that'll do it. Done. So that's guess and check in action. Okay. Now what I'm going to do is I'm going to do two things. I'm going to do guess and check again, but I'm going to systematize it a little bit, right? Because this one's not so easy. So there, I'm just going to forget that we know what it is. So here's what I'm going to do. I'm going to list all the factors of 12, right? So how can you factor 12? 1 times 12, 2 times 6, 3. Let's do it. I'm systematizing this, right? So we're going to start with 1 and 12. We're going to go with 2 and 6. We're going to go with 3 and 4, right? How can we factor 21? 1 and 21. Remember, systematic. You're always going to start with 1 and 21 and then 3 and 7, right? Okay. So I know that the 1 and the 12 could go with 1 and 21 in one of two fashions, right? So I can multiply across here. 12 times 21 is really, now keep in mind we want to get a 4, right? 12 times 21 is big and then 1. So I got a really big number that I can add 1 to or subtract 1 from, but that's not going to give me a 4. If I multiply this way, I've got 12 and 21. Well, 12 and 21 add to 33 or differ by 9, but I need a 4. So it's not going to be 1 and 12 with 1 and 21, right? So let's try 1 and 12 with 3 and 7. So that's 84 and 3. 84 and 3 cannot be combined to give me 4. Let's go this way. 36 and 7. That'll give me a 43, or 36 minus 7 is 29, not a 4. Okay, let's go to 3 and 4 next, because we know that that's not the answer, right? So 3 and 4 with 1 and 21. 84 and 3. No. 36, no, right? No, I'm not getting a 4 out of that. But 3 and 4 with 3 and 7, that's possible. 28 and 9. No. 28 and 9 either gives me 28 plus 9 or 28 minus 9, neither of which are 4, right? It's 37 or 19. How about this way? 12 and 21. Well, I can get a 9 or a 33. Nope, doesn't work. Okay, 2 and 6 with 1 and 21. Too big? No, not getting a 4, right? And that's like, I wouldn't even check the 1 and the 21. Like, not first, right? Because wait, it's too big. Okay, so what do we need? 3 and 7. Okay, 42 and 6. Nope. 18 and 14. Right? I can get a 4 out of that. So I know that the 6 and the 2 are the leaders. I know the 6 has to go with the 3, and I know that this, 7 has to go there. Okay, so what am I going to get? it's a D. 12D squared. Yep. 18 and 14. So I need minus 18 plus 14. Done. Okay, so that's a more systematized guess and check, right? So you can actually write it down and go through it. Now, we got this. Okay, I need two numbers that multiply to 12 times 21. What's 12 times 21? 252? I'm just about to come up with that. It's 210 plus 20. Yeah, okay. 252. I need two numbers that multiply to 252 and differ by 4. So what's the square root of 252? 15? Okay, so let's go 252 divided by 16. What do you got?
15.
All right, no good. 252 divided by 17.
14.4.
Okay, 252 divided by 18.
14.
18 and 14, right? Those are our two numbers. Okay, so what do we got? Plus which?
Plus 14 minus 18.
Right, so plus 14, right? How do I know, right? Well, because, so plus, it's got to be the smaller number and minus 18. Now, 12 doesn't go into either one of those, right? So you might say, well, 4 and 3. Yeah, that's not going to work. So what are we going to do with the 12? 6 times 2. The 6 goes into this, 2d minus 3. 2 goes into this, 6d plus 7. So 6d plus 7. And then you check, right? 12d squared minus 18d plus 14d gives me the minus 4d that I want, minus 21. Okay. You're going to mess up. Here's where you're going to mess up. You're going to get those signs reversed. You'll have 6d minus 7, 2d plus 3. Okay. So you always want to check your factorization, right? Take that moment, because it can save you a whole pile of grief later on. Okay, is there a common factor between 30, 81, and 84? The answer is 3. Yeah, okay, right? Because we know 3 goes into 30 and 81, and 84 is 3 more than 81, so it must go into there too. All right, so we can factor, now let's factor out a negative 3. So that'll give me 10m squared. I always want this to be positive, right? I don't want a leading negative term. So if the leading term's negative, factor a negative out, and then just do a normal factorization. Okay, what do we got here? So this will be minus 27m minus 28. Okay, now check that, because if you got this wrong, then guess what? Everything below this will be wrong. So negative 30m squared plus 81 plus 84. Okay, cool. So now I just got to factor this. So I'm guessing 5m, 2m, 28. How about 4 and 7? I put a 7 there, I'll get a 35, and I'll get a 4. Yeah, that'll do it. Minus 7 plus 4. Done, right? Guess and check. Hopefully that's right. Be embarrassing. Minus 35 plus 8. Yeah, it's even right. That's guess and check, right? You are not going to be that good for a while, right? You know, if you're doing, and there's some luck involved, right? Over the rainbow is going to be a little painful, but don't forget the negative 3, right? It's still there as a factor. Okay, so I got negative 3, and I'm going to do over the rainbow, so 10m, 10m, and a 10. Okay, two numbers that multiply to 280 and differ by 27. Multiply to 280, right, and differ by, so I don't worry about this, like I never do this, they multiply to negative 280 and they add to negative 27, that strains my head too much, right? Just, they multiply to 280 and they differ by 27, right? I mean, once I found the two numbers, I'll recognize them. So they're fairly far apart, right? Like, so 28 and 10, now they differ by 18, so we gotta move a little further out. So, I don't know, try 30. Is 30 going to 280? No? 40? Yeah, 40 and 7. And they don't differ by 27, so it's somewhere in between. So you got to play around for a while. So what are they? 14 and 14? 14 and 20? No. Yep, multiply to 280 and differ by 27. So I'd be going like 280 divided by 8. Right? So over the rainbow, right? This is multiply to 280. 35 and 8. Okay? So the 35 is going to be negative, right? And the 8 is going to be positive. See how long guess and check took? Like, took less time than trying to find two numbers that multiply to 280 and differ by 27. Okay, the 10's not going to go in, right? But 5 times 2, so 5 goes into this, 2m minus 7. 2 goes into this. Okay, so your final answer written out is this, right? Negative 3 times 5m plus 4 times 2m minus 7. Don't forget the negative 3, right? It's part of it. if you're using decomposition, you have to do the exact same two numbers that multiply. You got to get the 35 and the 8. It's a bit more painful to do the last couple of steps than it is doing it this way. This is a bit nicer. However, if you like decomposition, you use it, it works for you, then by all means. Oh, really? All right, what are we going to do here?
Let x equal 2x.
Okay, don't let x equal something that has an x in it. Pick any letter other than x.
Let a.
Let A, right? Z, B. So you got 25 other letters to choose from. Don't choose the one that's, because you say let x equal 2x plus 1, then it's sort of like, oh, well, I can solve that. That's an equation, and then x is that. We want to get there, right? So let A equal 2x plus 1. Okay, then what do we have? 3a squared plus 13a minus 10. Okay, now factor that by whatever method you like. Like, to me, this is where guess and check, because you know it's got to be 3a and a, right? There's no choice. Not like it's an 8, it could be 1 and 8 or 2 and 4. It's not like it's a 12, 1 and 12, 2 and 6, 3 and 4. It's like, it has to be 3a, and it has to be a, and it's got to be plus 5 and minus 2, and then we're done. Right? Don't think too much. I find that this method works better if you don't think too much. No, seriously, it just, go with the flow. It's sort of like, okay, what are the two numbers? It's not going to be 1 and 10, right? Now, check that. What do we got? 3a squared plus 15a minus 2a is plus 13a minus 10. Okay, good. Now what? Don't write an equal sign here. It doesn't really equal, but it leads to, so now we're going to say, all right, it's the 3 times the 2x plus 1 minus 2. And it's the 2x plus 1 plus 5. Okay. So now we say, you know what, really, there was no a in this thing. We just let it be a little stand-in that we were going to use so we could factor it a little more easily. And now we got to replace it. And you've got to make sure that your expression, that's why I always bracket this guy no matter what, right? Because here it matters. So this becomes 6x plus 3 minus 2, and this becomes 2x plus 1 plus 5, and that is equal to 6x what? Plus 1 and 2x plus 6. Now there's no easy way to check this, right? But you could go graph it. And just enter it exactly like you see. Y equals 3 bracket 2x plus 1 bracket squared. Plus 13 bracket 2x plus 1 bracket minus 10. Okay? And then just enter this exactly as you see it. Don't expand this. Like, who cares? Just, right? You can graph, it'll graph that just fine, right? It doesn't need 12x squared plus whatever that is, 38x plus 6, right? It doesn't need that. But who cares? So, I'm going to leave that there. What are we going to do here? The same thing, right? You don't have to, right? I mean, if you're good, you could just factor it the way it sits, right? You could just say, oh, but I'm not that good. And then say what we're doing, right? So let A. And make sure it's in brackets, right? 5x minus 2 brackets, right? It's that expression, okay? Which means, so you could say that leads to, so I'm not putting an equal sign, but I'm saying, okay, it leads me to this. It's got to be a 2a, 3a, right? And it's got to be a 2, 2, 2, 6, 2. Nope, it's not a 2, 2, so it's a 4, 1. 4. No, not that order, so 4, 1, minus. There we go. So minus 8 minus 3 is minus 11. Yes, okay. And then make sure that these guys are in brackets when you go to replace the A. Like, take your time. There are places to rush. Like if you're running to get the C train. Doing mathematics is never a time to rush. You don't want to be in a hurry. Okay? Because that's when you're just going to make mistakes. Right? You're in a hurry. Oh, then you start making mistakes. Okay. There's no A there. 15x. Well, that undone. You can take out a 5. And you can take out another 5. You can take out 2 5s. What do 2 5s taken out mean? No, it's 25. There's 5 out of each. So here, watch this. Equal. So at this point you say, hey, look, common factor. 5 times 2x minus 1. And then 5 times 3x, let's just throw that in brackets, minus 2. So 5 times 5 is 25. And then a 2x minus 1. And it's like, now I'm looking back at the original. Can I have, was there a common factor in the original? And the answer is no, there wasn't. Is there a common factor when I've got the 2a minus 1 and the 3a minus 4? No. So what happened? Well, just look, the way it worked out, it ends up there's a common factor of 5 in each parenthesis, right? And when those two come out, you have a factor of 5 times another factor of 5, right, which is 25. And then you've got the other factors, the 2x minus 1 and the 3x minus 2. If you're going to graph these, what's your y-intercept? So it's like positive 50, right? Y-intercept, you set x to 0, it gives me a negative 1 times a negative 2 is 2 times 25 is 50. Your x-intercepts are a half and 2/3, so, some things, the problem with checking this by graphing is you're going to have to get your window set. It's going to take you a little while to get the window. Nothing wrong with that if you're done the test. So was yesterday's test too long, too short, just right time-wise? Did you find, I had plenty of time and it was good, or I was rushed for time? It's like, I've never seen that question before. Maybe I should be doing a little bit more of the homework, right? Because there were some questions in the homework, like some of the questions on the test, right? And if you haven't seen them,
Speaking of which, you're gonna get that test back.
oh, at some point. Factoring differences of squares. Okay, so difference of squares is in the form a squared minus b squared. Remember we did this guy, right? We got 81x squared minus 16. The product of a pair of conjugates, right? Even used the word earlier, conjugates, is a difference of squares. In other words, a difference of squares factor. So when you see something squared minus something squared, then you know this is the factorization, right? So 49a squared minus 9. So this is always, if I see two terms, and there's a minus sign, then I always have to say, is that difference of squares? And the question is, does that have a square root? What is it? 7a. Does that have a square root? Okay, so that's how you factor it. Always do the plus factor first and the minus factor second. And there's a reason for that, which will become immediately obvious in the next question. So 16x to the fourth minus 1. So first, is there a common factor? No, right? 16 and 1. No common factor. Okay, so what's the square root of 16x to the fourth? 4x squared plus 1, and then 4x squared minus 1. And now what do you say? You say, haha, another difference of squares. So here's what's got to clue you in. Number one, you see a fourth power. As soon as you see a fourth power and you do your factorization into a difference of squares, that's why I do the plus and then the minus. This can't factor. A sum of squares, you're done. Nothing factor. This might factor. In this case, it does. So this is, don't forget the first factor. And then 2x plus 1. Okay, so fourth powers, eighth powers, anything, 9/25. What's the square root of 9/25? 3/5. What's the square root of 1/16? Okay, so your big thing is, does it have a square root, right? If I see two terms, first off, is there a common factor? Because if there is, and if there is, and I pull it out, will I then still have a difference of squares? Maybe, maybe not. I mean, kind of look. Two terms, both have square roots separated by minus sign. That's how you factor. Well, there's more. 2.56 actually has a square root, right? Which is, what is it, 1.6? So 1.6x plus 0.7 and 1.6x minus 0.7. Huh? Oh, you're right. Good catch. Yeah, so look for the square root of the actual term, not the one you imagine in your head is sitting there, right? Sometimes we do that. I don't feel like I didn't see the y. 100m squared minus 25. It's a common factor there, right? Which is 25. If we take that out, so like you could write this as 10m plus 5, 10m minus 5, and then you're going to go, oh wait, 10m and 5 have a common factor. So let's take out the 25 as a common factor and go 4m squared minus 1 and save ourselves having to factor it down at the bottom. So if you're writing 10m plus 5, 10m minus 5, you got to factor 5 out of each of them. In which case you're going to add them and get a 10 instead of multiply them and get a 25, right? Because that's how you guys roll, right? It's like, I'm going to make a mistake on this. Here's the mistake I will make. And I'll tell you, you'll make a mistake on this, and and you will. So, this is kind of weird, but what's the square root of 3x minus 5 squared?
3x minus 5.
Yes, 3x minus 5. So this is equal to 3x minus 5, okay, plus y squared, and then 3x minus 5, and then minus y squared. Now, the only reason I'm bracketing these is because you're going to see it in number 24. You'll see why I'm bracketing these. Right? It's like, you might say, why are you doing that? Because now I should remove the brackets, right? So it's 3x minus 5 plus y squared, and 3x minus 5 minus y squared. In a certain sense, it really doesn't matter what order any of those are written in. I mean, if you multiplied it out, you get the same things. Okay, what's the square root of 9? What's the square root of 2x plus 1 quantity squared? 2x plus 1, which I'm going to keep in brackets, right? And then 3 minus 2x plus 1. So here's the reason the brackets are there, right? It's for this, because that's going to be minus 2x minus 2. So now we're going to go through and remove the brackets. 3 plus 2x plus 1, and 3 minus 2x minus 1, right? Because this negative sign has to be distributed through this set of brackets. So this is going to be like 2x plus 4, and it's going to be like 2 minus 2x. Oh, God, it's all even everywhere. So this is going to be 2 times x plus 2. That's going to be 2 times 1 minus x. So it's 4 times x plus 2 times 1 minus x. Right, so it turned out they're both even. We had to take it out. There's nothing we could have done ahead of time. Right, should be a bracket there. Right, there's nothing you could do. Okay, same deal, right? What's this one? So you look at it, you should say, oh, that's a difference of squares, right? Now we could let A equal the first one and B equal the second, but we don't need to. So we know the square root of this is 7x minus 2, and we are going to add the square root of this, which is 5x plus 3. And we're going to do the exact same thing, only this time we're going to subtract. Okay, so square root of the first term, which is 7x minus 2, plus the square root of the second term, which is 5x plus 3. Then the square root of the first term, which is 7x minus 2, minus the square root of the second term, which is 5x plus 3. Everything's nicely bracketed, so now we can go through and remove brackets, which is going to make no difference to what we write in the first set, and it's going to make a big difference in the second set. Okay, and then we collect. So we get 12x plus 1, and we get 2x minus 5. Okay, and there's virtually no easy way to check that, right? You could graph it, but, you know, good luck finding a window and stuff, right? There's certain things, like, you know, when you finish a test and it's time to go back and check stuff, you gotta kind of, you know, check sort of the easy stuff, you know, and stuff like this that's, you know, if you have a lot of time, great. You know, you can go back and check stuff like that, but at some point you're better off just going through your algebra and just making sure, did I distribute the negative sign correctly? Okay, so notice it says complete textbook. Complete the textbook work before attempting the questions below, right? Okay, so, you know, we're done. I don't expect you to do it. There's not that much time left. So tomorrow you come in, you've got the outline, it lists the textbook work, right? Do that first, then do these, right? Because they're, you know, this is taking it up a notch. Okay, so textbook work is what's listed under tomorrow for questions, and